Let's review HVAC blocks together via the telediagram program. First, let's discuss the floating motor. Our floating motor block is used proportionally to open and close a system. We have taken the operation time block to observe the opening time. We also connected a block to the closing output. We'll examine it in seconds. We use a word register block to enter data. We will enter the full opening and minimum opening times, and also observe the opening status of the valve. Now let's install a device with these project and start online monitoring on the current project. Let's establish the connection to the device and start online monitoring. Initially, the live monitoring of what we see in gray is not active. We can right-click to activate their monitoring. Now let's set the full opening time to 10 seconds. We set it to reach 10 seconds and minimum to 0. It will reach from 0 to 10 seconds. And we entered 50 as the value, expecting it to reach 50% change, meaning it should achieve full opening for 5 seconds. When we increased it to 60, we saw it increased by 1 second. We're going proportionally. Think of it like 100%. When we set it to 100%, we will see a value of 10. So, it sends an opening signal for 10 seconds. Now let's slowly look at the closing. We said 90. We saw an increase in the closing time. So, the closing output goes to position 1. Let's say we entered 6,000 data. If I say it's 50%, there will be a 3-second increase. As seen, it went up from 10 to 13. Let's do another example. If we set the value to 40, there was a decrease of 1. As seen, proportional changes occur in this way. Now let's move on to our other block. Aging member block. Let's look at how the aging process is done together. First of all, there must be an aging manager for the aging process. We can enter the number of slaves to work together into the object properties of the aging manager block or set it from the outside. Let's use a binary register block to start from the outside and set the number of working slaves by connecting a word register block. And the aging manager works together with the aging member. By connecting the manager output to the member inputs, we make the RTU aware of how many blocks it will control. For example, here we connected 2. The software will control both in this case. Also, if we specify one of the working slaves, for example, one of the 2, we will control 1. We connected the high door to the active input of the block. Because for the blocks to be used, it must be in one of its active inputs. Now let's start with examples. First, let's use a relay output block for control. That is, we connect the output of the block, which we will control from 0 to 1, to the We have the chance to see how long the block has been in error from the run-out output. We connected an runtime block to monitor these times. Let's connect a word flag block to the operation time output. We will manually set the working information. So, we connected a binary register block. If the working information does not come during the defined time in the error time, the block will automatically fall into error. We need to connect a binary register block to the error input to provide this error information. In our example, let's make the operation time 1 minute and the error time 40 seconds. If the working information does not come for 40 seconds, the block will automatically fall into error. That is, the block's working output will go to position 0. We add registers to reset errors. Since we set the operation time from within the block, we didn't To reset the error, a binary register block is connected to the error reset input. Before loading, we activated live monitoring for all blocks. Then let's connect to the device and do our test together. We started online monitoring. We saw that both roll outputs are 1. Because both of them are wanted to work at the same time, the working information should come. For example, we gave the working information to the aging member connected to relay 0 above. We did not give the working information to the other one. It waits for the working information for 40 seconds. And at the end of 40 seconds, the error time starts to increase. In the other block, since we sent the working information, the operation time starts to increase based on seconds. You can receive these information from the block outputs. So, we have the chance to observe how many seconds it stayed in error. Until when? The block stays in error until a trigger comes to the error reset input. We send a trigger to the error reset input, the aging member block becomes active again. And it waits for the working information within 40 seconds. This time we gave a trigger to the working information. So, we ran both aging member blocks at the same time. This time let's do synchronous aging. That is, let one of them work. Let's see how to control it together. When we started, we saw that roll 0 was deactive and roll 1 was at 1 position. We gave the working information manually. Actually, it should be a physical, digital input information. It should come from the device. If there is a thermal fault, etc., it should also be connected to the error input. There is no problem at the moment as seen. Let's send one to the error input. As soon as we send it, roll 1 goes to position 0 while roll 0 comes into play. That is, it's as if the block connected to roll 0 is in error. While the error time increases, let's bring it back to position 0 again. After the error is repaired, we brought it back to position 0 like pressing the reset button for the error. The error time stopped. At the moment, we also sent the working information. Let's bring it back to 0 again. Again, if the working information does not come for 40 seconds, it will return to 0 again. But since we want it to work properly, we sent 1 to the working input of roll 0. As seen in the word flag block, it shows that it has been working for a minute on the block. These blocks have a persistence feature. Even if it receives a reset, you can observe how many minutes it has been working. The other block has now reached 1 minute. It has been active for 1 minute. This time when we decrease the working information, after a minute, roll 0 goes to 0 position, while roll 1 goes to position 1. So, such a synchronous aging is done. When the roll output is active and the error information comes in, it will directly drop the block output to 0, or if the working information does not come for the defined time, the error time, it will drop it back to 0 position. Synchronous aging blocks work like this.